So this is 2019 B2 higher level conics. A little bit unusual in that a hyperbola has came up on it, but we'll have a look at it and see. It's a fairly doable one. Nothing overly complicated in it. So we read the question here. It says the image shows the De Lacy Bridge in Drogheda, which is context. The projections of the bridge are shown below. So not too much there when you touch line. The curve ABC is a parabola. So basically, this elevation view is a parabola with the vertex at B, as you'd sort of expect by looking at it. Draw the given elevation. So again, that's the first thing we should do. The curves DEF and PQS are branches of a double hyperbola. Okay, so you'll see a double hyperbola. Again, the way we're used to doing it for the hyperboloid of revolution, this is V1 and this is V2. So the only sort of unusual thing is that it's quite a squashed version of it compared to the hyperboloid of revolution when it's quite extended. But again, the construction is exactly the same. The vertices are E and Q, okay, V1 and V2. The construction of the portion DE of one branch is shown. So that's basically what you're given. So again, even if you'd forgot the construction, it's shown there how to do it. HLG is a straight line. So this line here is a straight line. And then we have a bit of a radius here. Now, the only thing I suppose, just when I'm looking at that, is just to make sure we've a bit of space maybe from here to here to get that arc. But it wouldn't really matter if you went up onto that. So we'll give it a go. It says, and then part C, it says, in the elevation, the focus of the parabola ABC is 4.9 millimeters from vertex B. We might mark that in. And it says, locate the focus and draw a line which is tangential. We may not cover that tangential part in this video, but we'll do part A and B anyway. We may just quickly mark in the start of part C. So I don't think I'm going to have anything above here. The scale is 1:100, so 81 millimeters will be 8.1 meters will be 81 millimeters. I'll come down about 90 to start. It's 25.2 meters or 252 millimeters across. So that should fit. It should be fine. So I'm just going to put a 0 mark there. And let's see, we'll go to 15 and then I'll go another 102. Yeah, so it seems to be fine. I'm probably in about 10 or 20 from one side. Okay, so there's my two sides and I'll just draw my box for my parabola. So I'll just do the elevation here first. So my height to my elevation is 81 millimeters. I'll put it marked like so. Okay, so that looks pretty good. So I have my rectangle there for my parabola. So as per usual, we'd split it in half. So half of 25.2 is 12.6 or 126 millimeters. So we'll draw that up. Okay. Now, usually I'd split this into 5, but what I'm going to do carefully here is just count out these gaps so that rather than me splitting it into 5, constructing the parabola, and then having to draw these single lines here for the uprights. Actually, I was going to say I have to figure out mine. They're given a distance here, 1.8, but I'll count them out anyway. So I have 1, 2, 3, 4, 5, 6, 7. So I have 7 splits there. So more than I normally do, but makes life easy because if I use the same, I won't have to go and construct it again. So 1.8 and 1.8 is 3.6, and 1.8 is 5.4 or 54 millimeters, and 1.8 or 18 is 72, and 90 and 108 and 126, which is what I'd expect. So I'll do the same here. Just be careful that I don't get mixed up with that mark that I used already just to set out the distances. So 32, what do we say, 48, 7, no, 6, 1.8, no, sorry, it's not. It's 1.8 and 1.8 is 32, 1.8 is 54. Yeah, sorry, and then 1.8 is 72 and 90, so I made one mistake, mark that in 108 and then 126, so this one is the right one. So I'll draw these, I'll just draw my right ones up. So it doesn't matter, you could split it into 5 if you wanted. There's no reason why that would be incorrect, but this way will give me a good number of points. And they'll also line up with exactly with the lines that I have. Okay, so because of this, oh, it does. Does it divide by 7? No, it doesn't. Okay, I thought maybe this might divide exactly by 7. It doesn't. So what we'll do is we'll draw, I'll use a different colour for my divisional line. Draw a random line out here. We'll do 7 equal parts. So we'll do every 10 millimeters. Okay, join the last one back like so. And then use sliding set squares, or we can use our set square and our t-square. Now if we're doing this, you can't see this, keep one of the edges of the t-squares in. This is just exactly the same as sliding set squares method. It's an alternative way of doing it. Some of you will have looked at this in class, but if you're not used to it, just use your normal sliding set squares. I can't lay my hand on a second set square easy. But usually actually this is a slightly more accurate way. Okay, so there's my splits done, and again I've proven that I can do that. So I'll join these up to the vertex. And I could do the original line method on the other side, but I'll just literally mark it over. Okay. Okay, so these ones here need to go up a little bit further. Most of the rest of them are adequately high enough. So because I have so many, I'll probably just number them as well. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 6. Okay, I made a small mistake there. Oh, it should be that line. And we got it right on the other side. Okay, but anyways, what I'll do is I'll heavy this in just to see where I'm in next. So that's the correct one. This is the correct one. So ignore that other line. Sorry, that's the wrong point. Okay, it's quite a shallow grab. Okay, and do the same on this side. So I have the elevation of the parabola done. So I'll just heavy in, I assume they're sort of a steel wire that's holding the bridge up. Okay, I think I joined heavy the wrong one. But anyways, for the main part it's correct. You might notice my gap there is a tiny bit thinner. I should have heavied this one, so I fixed it. Then accidentally I should have heavied it at the time. But that's that view done. Okay, I could number it on the other side, but I'm happy enough with that. And as I said, so the only other thing then I want to just make sure is that I have enough space here. So we don't know how far out H is yet, but we could make an estimation. So if we look here, we can see that 4 meters roughly estimates to be 1 centimeter, right? And this is roughly another 1.7 or 1.8 up. So it's roughly another 4 meters plus another 3, you could say. So if we want to come down to this point, we come down 7 meters, and that's going to be my point D. Okay. And let me just say 4, and 4 is 8. I think I'm going to have a small problem here, in that if I come down that far, this point here is going to go off the page. Let's mark that for a second. So in order for this question to fit, I'm just marking out, just getting it right for you for the exact for when you're drawing it. If you want to fit it on an A3 page, you're going to have a small problem if you want to use that point exactly where it is. But it doesn't matter if this point comes up into here for the sake of construction. What does matter is that I have enough space here from the bottom. So what I'm going to do is instead I'm going to come up 7 meters. And I'm going to mark my 40, so from F to the center. Okay, so that's pretty okay. I'm going to mark another 40. Okay. And there's basically the center. So the only thing that's really going to probably go out of course is just this point here is probably going to end up here. Okay. So we'll see how this works out. We can always change it for when you're actually doing it otherwise. So what I've done there, just I suppose just to explain to make sure that people understand what I've drawn, is I've drawn those lines there. Okay. So what I'm going to do is bring down this point here. We're then shown that this is 2 in from the middle. So 1, 2. This is 2 from here, so make sure I mark the right one. This is what they call E. And this is what they call Q, or I'm going to refer to it as V1 and V2, like we're used to. Okay, that's the easiest way to think about it if you're used to doing it that way. So what I'm going to do is I'm going to split 4 into 5. We'll just see how many parts. 1, 2, 3, 4, 5. They split into 5. That's what I normally would do, but I just wanted to check that that's what they did. So 8, 16, 24, 32. Well, I'll just do one side, I suppose, first, just not to make mistakes. So this here is 90. This is 5 splits. 90 doesn't divide. Oh, it does divide by 5. Sorry, it's not 4. So 90 to 5 is 18. So we've 18. Oh, it's the same splits that I have here. Okay, so they made that easy for me. So I can use them bits there. So these ones here will go to V1. And these ones here will go to V2. So I suppose my marker is a little bit thick, ideally for this in such a small space, but it should be accurate enough for most of what we want to get done. So I'll take my purple here and I'll mark where 1 and 1 cross. 1, 1, 2, 2, 3, 3, 4, 4. Where 1 and 1 cross gives me a point, where 2 and 2 cross gives me a point, 3 and 3, 4 and 4. There's my final point. It's quite a distance to try to get the first one, so it's a little bit hard. The rest of them aren't too bad. Okay, so there's that bit there. So I'll just repeat what I did there then on the other sides. Now if you want, you could mirror them. I'm just going to repeat it because it's easier, I think, but what I'll do is I'll just use a different colour just for the marking of it. Okay, so 8, 16, 24, 32. Let's put our marks here. And same, I'll do these marks here on this side. I should mark top and bottom at the same time, make life easy for myself. And again, I can just bring these up. Okay. So a mirror method is completely acceptable as well, but depends on what you want, what you prefer, right? So you could mirror them down the way and then mirror them across. Just draw a line down the center. But I'm just going to continue with my construction. So this one goes to here. And again, if you got confused, like there for a second, it took me a second just to think, if you join them the wrong way around, they wouldn't crisscross over each other. So it should become apparent fairly quickly. Okay, and we bring down these ones. So I suppose the only disadvantage of this method over the mirror method is all of a sudden you have tons and tons of lines on top of each other, which makes it a little bit more difficult to see. But as long as you keep them light, it's whatever you prefer. There's no, not specified that you have to use a specific method. So hopefully you can sort of see there that that's like the hyperboloid of revolution that we're used to doing. Construction, sorry, I marked the wrong point there. So again, if you number them, if you're stuck on anyways, might make it easier. So there's basically, let's see if I highlight them, these two bits here, constructed. So I will probably go about constructing the road next. So again, you're looking out for these little symbols. So it's a little bit difficult to see, but they look like sort of a sideways equal sign, basically like that. What that means is they're 5 equal splits. So on the third one here, or basically if you want to divide it down 1.6 millimeters in or 16 millimeters, you have a road. And then it's hidden detail. Oh, I won't heavy in it completely because I haven't constructed the line in the middle, so I don't know exactly what the hidden detail is, but I'll just use a pink maybe just to mark where the road is. Okay, so you can see there basically that there's 2 out of the 5 splits is where it starts, so that will be 8 divided by 5 is 0.8 of a meter, and 2 of that in will be 1.6 meter or 16 millimeters. Okay, so I'm happy enough with that so far. So there's basically my blue lines is the road on this side. I haven't done this part yet. So what that does is that gives me G, or does it? No, what other bit of information do I need? HLG is a straight line, and we know that this is 90 degrees to this, and we know that it touches this line, but do we know exactly where it touches? We don't seem to. So I'm just trying to see, is there some other bit of information? We know this is perfect. Well, we have to find that point, and then that'll be the radius. That's 90 degrees. That's 90 degrees. I'm just thinking, do we have to draw it? Anyways, we need a center line, so we'll start with that part. So we can draw our center line down the middle, and we go with the bottom part for the basic reason that it's I have enough space for it to see. So what we know is basically this is going to hit somewhere here and come out at 90 degrees. I'm just trying to see, is there some simple bit of information that I'm missing? Ah, sorry, it took me a second. Point G, I knew there was something, is level with this. Okay, so that's my point 2 in, which is the same as this. So it's actually there. Sorry, I couldn't figure out what I couldn't see. Okay, so those, I could have actually heavied this in. So those two, that gives me G here. So basically what it is the top of that, or if you want, you can bring it down from this point here. I won't bring down on the other side just because I have mismeasured it, as I said. I can show it there. Right, that's the one that should be heavied. Okay, so that gives me these here as being solid, and this here as being hidden. Okay, now sometimes like that it takes a while to figure out what the bit you're missing is, but if that's the case in the exam and you spend a few minutes and you can't figure it out, you should just continue on and put it in as best you can. So what I have there is basically point G. So we know that this is basically going to go at 90 degrees through here, through the center point, and then we're going to draw some bit of a curve here for how it intersects. So we have to locate that point exactly, and we know that that's a straight line. And do we know a radius? No, but we do know it goes through point L as well. Okay, so again, yeah, oh, HLG. Okay, so there you go. I should have marked point L. So again, point L is important. So L is the second one in. So it's this one. So there's a few unusual bits there. So basically it's from this point through the second point up. So I can mark that on all sides. It's actually simpler than I thought, but it just took a while to see exactly where the points are that they were talking about. Again, the second point here. Okay, so if you have your adjustable set square, you could set it to this angle and just go at 90 degrees. It's going to be difficult for me to fit it on such a small board, so I'm just going to draw it out like this. So I'll balance that there. Bring that out at 90 degrees. Where that hits there gives me my center point, and then I'll draw my curve. So I thought there'd be more to construction of this, but the difficulty in it was actually seeing the points that they were looking for. Just checking that I'm accurate. It must be a little bit to the left. So I'm just checking that it's going to touch the 2 points accurately. So there we go. And then whatever distance it was on this side, that's 80 millimeters. I should probably transfer it with my compass, but I just have it set. So that's 80 millimeters. So all I've done there is I've slid this up a bit closer. My distance is the same. I'm not going to go over either view. So I'll show you how I've extended that up just so that you can see. So all I've done there is basically made that distance there to the distance away from the road with the same distance here. And that's the question completed. I suppose if we wanted to just check this bit here, it says locate the vertex. Focus is located 4.9 meters away from the vertex. We know that this is the vertex here, right? They called it B, and we know that it must be in this way from our conics, so it's actually 4.9 meters, which is there. So we'll mark it as F, and we'll explain this other bit about how to do the point tangential to the parabola from C. But what you could do is you could always just join it together because that's going to be the start of it. Okay.